All right, let's see if we can go over Chapter 6B test. I know that they're in a different order for you, but I'm looking at, I think, the correct order as the way it's presented in your review. So I'm looking at the interest is compounded continuously, and you have, this is problem 1 for me, 5.25% interest is earned, and the money that has accumulated is $8,500 in 10 years. It says what was the initial investment. Okay, so y equals y naught and compounded, or I guess I should say PE to the RT, the initial investment being P. Okay, so we have 8,500 is what you have now. We're trying to figure out what the initial investment was, e to the 0.0525 times the 10 years, and you end up solving for P, and P ends up being 5,028.22. Okay, when we're rounding with money for BC Calc, I know we do 3 decimal places, but if you're talking about money, let's just go to 2, because really the thousandths place really doesn't make any sense. Okay, in how many years will the investment be doubled? Well, you have to know that y over p is going to be 2 is equal to e to the 0.0525 t, and you're solving for t, and that t would have been 13.203 years. So this was A, this was B, and then at what rate will the total amount be increasing when the money is doubled? So for this one, the money is doubled when t equals 13.203. Oh, at what rate will the total amount be increasing? Okay, this is where you have to know that when we have this situation, this is going to be at what rate. We're talking about rate of change here. So dy dt is equal to, well, right now our initial investment is 5,028.22, and then it's e to the 0.0525t. Actually, that's y. Okay. So you either had to take the derivative at when it's doubled, okay, or you know that dy dt is equal to that 0.0525 times y, and when the initial amount is doubled, that means that we have 2 times that, so 0.0525, 2 times that 5028.22. So understanding that dy dt is equal to ky. Y is the amount that's present, which is double the initial investment, and k is your interest rate. Okay, so a lot of people tried to find rate as in interest rate, and they were talking about rate of change. Okay, for problem 2, the rare Tweety bird, when they told you that on January 1st, so that's your initial, so that's at time t equals 0, and you would have had 10,000, and then on January 16th, okay, which is 15 days, there were 9,000. So we had some discrepancies as far as the ordered pairs are concerned. So check that and go get your K value, okay? Now what I did is I tried to give you credit, like if you got I'm looking for the final or the equation of this, okay? So if I know that this is the initial, so y equals 10,000 times e to the kt. I don't have k, I need to go get it. So now I have 9,000 is equal to 10,000 e to the k, and that happened in 15 days. Okay, and if I solve for k, k is going to be the natural log of 9/10 over 15. Okay, if you're struggling with that algebra, maybe you should show it. And so the answer to that would have been y equals 10,000 e to the natural log of 9/10 over 15 times t. Okay, that's what I was looking for. So then now in how many days will there be 5,000 birds? So now you're looking at 5,000 equals 10,000 e to the natural log of 9/10 over 15, and you're solving for t. So your t value would have been different. I had a lot of people choose 16 for this and opposed to 15. So that's why I didn't mark off for 2b, because you used your equation, okay, but I probably docked you on whether or not you were able to get k. Okay, so for part B for that would have solved t is equal to 98.62. Again, when you're doing 682, sorry, and that was days. When you're doing these corrections, I should see your work. I shouldn't see what I have here, because I actually want to see the algebra that you're using. The next one was the first logistics equation, which I'll be honest, I was really impressed. We did okay with that. So dB dt, if you go through, you're going to get 1 over 3,000 b times 2,000 minus b, something to that effect. Okay. And if you separate, so we're going to go with dB, and actually I'm going to rewrite this. This is going to be 1 over b times 2,000 minus b. dB is equal to 1 over 3,000 dt. And so now I've got to integrate, but I have to do partial fractions, and that ends up being 1 over 2,000, and it's times the integral of 1 over b dB plus 1 over 2,000 minus b. Okay, dB. So I end up with 1 over 2,000 times the natural log of b minus the natural log of 2,000 minus b, and that's an absolute value, is equal to 1 over 3,000 t plus c. Okay, from here I can keep this as 1 over 2,000. This is going to be natural log of b over 2,000 minus b is equal to 1 over 3,000 t plus c. Okay, so then we're going to have this is equal to, this ends up being 2/3 t plus c. The constant doesn't change, so now I'm going to flip, okay, or actually I'm going to do e. So this ends up being b over 2,000 minus b is equal to c e to the 2/3 t. If I flip it, this is 2,000 minus b is equal to, and it'll end up being c e to the negative 2/3 t, and this will be over b. So now I have 2,000 over b minus 1 equals c e to the negative 2/3 t. all my goal is right now is to find what b of t is, even with that constant. So I get 2,000 over b is equal to 1 plus ce to the negative 2/3 t. And if I flip it again, b over 2,000 is going to be equal to 1 over 1 plus ce to the negative 2/3 t. So I know that b of t is equal to 2,000 over 1 plus ce to the negative 2/3 t. And if I solve for c, what do I know? I know that there are initially 1,000 white blood cells. So if I do 1,000, and that's at time t equals 0, well, t equals 0 is just going to be 1 over 1 plus c, because this whole thing will go to 1. So if I solve for c, I end up getting c is 1. So to get that b of t equation, it's 2,000 over 1 plus e to the negative 2/3 t. Okay, so in how many days will it take the blood count to equal 1,500? So we're just doing some algebra 2. 1,500 equals 2,000 over 1 plus e to the negative 2/3 t. Okay, and solve for that. Again, practice your algebra. T equals 1.648 days. You need some work to solve for that. All right. Okay. Last couple here on the calculator portion. We have P is equal to 150 over this 1 plus 10 e to the negative 0.002 t. And the first thing is to find the initial value. So P of 0, that's just plugging in 0 for t. I get 150 over 11, okay, which was 13.636. But now the limit, this is the one people missed as t goes to infinity of P of t, right? So if this goes to infinity, that means this guy is going to infinity, which means I have e to the negative giant number, which is going to 0. I'm sorry, the exponent's going to, that's going to 0, right? So this whole thing, because I'm going to have 10 divided by giant number, right? So that whole thing's going to 0. So literally, I have 150 over 1. Okay, and let me bring you to this. This is an logistically growing equation. Okay, remember the graph? That right there is that carrying capacity. And that's what happens, capacity. Okay, that's what happens when you go to infinity with time. That's how much population that the environment can handle. Okay, at what time will it be within 95% of the carrying capacity? Well, the carrying capacity is 150. So I need 95% of 150. This was just like was on the review. So those of you who skipped out on the review didn't necessarily get that, which was 142.5 is equal to, and we're going to, again, algebra 2, 150 over 1 plus 10e to the negative 0.002 t, and you solve for t. Okay. At what time will the population be increasing the fastest? What is the best description? Well, increasing the fastest, all of you are okay when it's half the carrying capacity. And half of 150, we get 75. So 75 equals 150 over 1 plus 10 e to the negative 0.002 t. That's not the issue. Everybody was able to get the time, but what is the best description of this point in reference to P? In reference to P, here it is, okay? This is the function P of t. That is our inflection point. So when is it increasing the fastest? That is point of inflection. We had a lot of people miss that. So you have to know that that is a point of inflection. Okay. Going on to problem 6, which was non-calculator. So now I'm just doing non-calc. Okay. And you have dy dt is equal to t over y squared. And you have y of 0 equals -8. Okay. So this one should be pretty foolproof because once you get your equation, you have an ordered pair to use to check your answer. So right away, we're going to separate variables. So y squared dy, no problem, t dt. Now we're going to integrate. So 1/3 y squared, nope, y cubed, sorry, is equal to 1/2 t squared plus c. Okay, now this is where people started to just plug in 0, -8, and they started to get really bad answers or bad math was happening. Here's what I propose. I propose that you solve for y. So I would get 3/2 t squared plus another constant because 3 times a constant is still a constant. So I can just leave that alone. And now to solve, I need the cube root. So y is the cube root of 3/2 t squared plus c. But now I have y of 0 equals -8. So I know this is going to be -8 is equal to cube root 3/2 0 squared plus c. Okay, so -8 is equal to the cube root of 0 plus c. So I'm going to cube both sides, and I get that -8 to the 3rd power is going to be my constant. Okay, well, -8 cubed is going to be 512. So y equals the cube root of 3/2 t squared minus 512. Okay, now we had some kind of crazy stuff going on like right here where people were plugging in their initial into this, and that's fine, but then you have to go and solve for y anyway afterwards when you already have a different constant. So you won't get -512. You should get 512 when you go through and solve for y. Now, what should you do? You should go and check to make sure that 0 plugging in for t gives you that -8, okay? Euler's method. I felt like everybody was on their A game with Euler's method. Okay, so if you have a question, I'm looking at problem 7 here. Euler's method, if you have a specific question on Euler's method, consult your notes or you can come into academic support time. For number 8, the graph needed to be some sort of oval shape that you could see that there was a point through 2, 1. Okay, so I was looking for 2, 1, whatever that was going to look like, but you had to have a point on there. Okay, for the next matching questions for our slope fields, the best advice I can give you is when you have, let's say, for example, dy dx is equal to sine x. When you have to match which of these slope fields represents this, remember slope fields reveal the original function because they're giving you the picture of what all these possible functions look like with a constant repeated over and over and over again. Okay, so what you have to remember is that if I take the integral, okay, this is going to be negative cosine x plus c. So I'm looking for a negative cosine graph, okay? Same thing with the last one. When it says y equals regular cosine x, okay, well now I'm looking for which curve looks like a regular cosine curve, okay? For the one right up above it, when you have y equals x squared. Y equals x squared, which of these curves looks like a family of parabolas, okay? Looks like h to me, done, okay? With the other ones that involve both x and y, for let's say for when it says dy dx is equal to x plus y. When I see these, I am trying to figure out what numbers for x and y, so what ordered pairs would give me 0, because then I know that I have a horizontal tangent. Well, it just so happens that 1 comma negative 1, if I add those guys, it will be 0. 2, negative 2 will be 0. So at these ordered pairs, I should see a horizontal line. Same thing with negative 2, positive 2. If I add those two together, okay, so if I go to these individual ordered pairs, there is a horizontal line at each of them. So that's what I'm trying to match up. Same thing when it says dy dx is equal to x minus y. I'm trying to think to myself, when will that be 0? Well, whenever it's 1 comma 1, 2 comma 2, 3 comma 3. How about negative 1 comma negative 1? 1 minus a negative 1 is going to be 0. So I will see these horizontal tangents all through those lines. Okay. All right. For the last one, the last couple, those are old integration problems. So that's from chapter 6A. And then we had multiple choice. So the total was actually out of 67 points. So if you're wondering, if you're looking at your grade and you're saying, oh my gosh, I got a terrible grade, okay, remember the last 3 questions were multiple choice, the last 3 questions were extra credit, and they were worth 3 points each. So there are 9 extra points that you could have earned, but I only took the total out of 67. So if that makes you feel a little bit better, or if you're thinking, wait, she must have screwed up because I got way lower on the test and then entered in something. And don't forget, if you did all of your homework, you got 5 extra percentage points added back on this test. Okay, let me know if you have any questions. I will be in academic support Monday and Wednesday next week. All right, have a great weekend.